Well, hi, and thank you so much for joining me in my shop. I've just finished replacing all the paper capacitors in this radio. So you see all these yellow and green capacitors are the replacements. And we're going to test it now. So let's drop it. Jeez, I've never dropped a radio before like that. I didn't do it any harm. No harm done. As long as I don't drop it to the floor. That would be better. A little worse. We gotta put a speaker on here. We need a speaker. I'll need a speaker and an antenna. Although this is just going to be a quick test of the radio. I'm not going to do too much with it, so I say now. Okay, that should be good enough for the speaker. And the antenna, we will use a clip lead on that. Now I have to make sure my outdoor antenna is connected in my office, because I think I have it disconnected at the moment. Let me just check. No, it's connected fine. Okay, so switch off. Okay, a little cleanup before we do this. It's part of my safety process here is to not have things too cluttered when I energize a radio. Is everybody ready? Somewhere we got a hum. As soon as I hit the power, I could hear a hum. Where the heck did that come from? Because the radio's turned off. Shouldn't hear anything from here. It's a hum coming out of the speaker. This radio's on. Oh, that's right, I shorted the switch out because we were suspicious that the switch was bad. Duh. Okay. It's a nice quiet hiss coming out of it. Let's put the antenna on. Oh, isn't that good? I like that. Now, this is AM shortwave and phono, I believe, is the three possible settings here. Oh, not with that. 4 settings. So that would be phono. What the heck is that? It sure is different than it was, that's for sure. Well, that's pretty interesting. Let's try the next band up. That was ham radio there. Okay, now we'll try the next band up. The top band, I believe it's 6 megahertz to 16. So we expect to get something up around, up in the higher bands here. Still kind of crackly, eh? It's getting something. Now, hear that terrible crackling coming. That's what I was trying to defeat on all bands. Well, I think we got an improvement in the operation of the radio. Listen to it. Did you hear that? It's almost as if the, my imagination says the capacitance of the failing capacitor is changing, I guess, or the effect, the electronic effect of it is changing. And the quality of resonance in the, see, it seems to get a little stronger with some of the crackling. Or I have the feeling some of you will be yelling resistor, resistor, resistor at this point. So maybe that's what we'll do next. We'll take a close look at the resistors. Maybe I'll try to signal trace this static and try to narrow it down even further. And of course, what I'm worried about is that it's coming out of these one of these two cans. It could even be coming out of both. I really don't want to get into them, but anyway, we made some progress. The radio's working now. I don't think it was really working. Oh well, that's pretty good for a test. Like I say, next time I think we'll go through, we'll check some resistors. That's something I really have seldom done. Unless I see them burned out, I generally don't check them all. But let's do that. And like I say, maybe I'll use my scope and see if I can't kind of isolate where the static is starting. What part of the radio would be kind of challenging too. I do have the schematic and all the information, so I think it's a thumbs up on this one so far. And maybe one or two more steps. Maybe the resistors, maybe dealing with these IFs, and it'll be good to go. So there we are. Thanks for watching, and stay tuned, because I'm going to get this guy to work.